So today you were asked to open up that same link from before, but you were asked to look at part 3, okay? And if you turned on part 3, you kind of see how it's moving back and forth depending upon our values, right? And you can move your A value up as well. So you were asked to kind of mess around and see what happens when A is positive and negative. So similar to yesterday, what side of the x-axis is on. And then what did that B value do? So hopefully when you were to fill this out, you were able to graph them, and you were supposed to notice when A is less than B. And again, using this form right up here. So when A is less than B, there was a loop. When it was equal to each other, it kind of looked like a heart. And when it's greater, there was like a dent or kind of like a clam, you could say. Kind of like a apple with a little dent, but not quite as much as the heart there. And then again, you were asked to do it with the sign. And you were asked to compare some different things. So some things that you would notice, symmetry. Some things I hope you noticed. You might have noticed others. Cosine has x-axis. Sine always has y-axis symmetry. All right, and then you could notice some different things about the distance from the poles and all that exploration. So these that we watched today are called limacons, okay? And so our limacons are the form r equals a plus b cosine of theta, and r equals a plus b sine of theta. Okay, so when a is less than b, it has a loop. When a was equal to b, it's something called a cardioid, which is like our heart. And when the absolute value of A was greater than the absolute value of B, it made that dent or the clam. And you'll notice those radiuses change it. So the max radius is if you add them together. And the minimum radius is if you subtracted them. All right, so if we go back to this and we were to take a look at that, so let's have our A value be 4 and our B value 5. So we can see in here how A is less than B. So for example, we had r equals 4 plus 5, the cosine of theta. So what do we know? We know this is a loop on the x-axis, right? And if we were to draw this, make a little rough sketch here. It has that loop, that's a terrible. And when it talks about the minimum radius from here to here, so that's 1. And from here to here, that radius, you add them together and is a distance of 9. So now if they were to equal each other, so 4 and 4, we can see how that's a heart. And that distance, that is 8. So r equals 4 plus 4 cosine of theta. Again, we know this is the x-axis, and we know it makes that heart shape. and then 4 minus 4, so that has a 0 there. And then our radius here was 8. And then let's look when A is greater. So we have 5 and 4, so we can see it's kind of that little dent. And again, our max radius, 4 plus 5 is 9. And if we subtract it, it's 1. So what did we have there? We had r equals 5 plus 4, the cosine of theta. I'm terrible at drawing these. Kind of like a little dent. This distance was 1, and this distance was 9. And you'll also notice that distance up and down is our A value of 5. So it intersected up here at 5 and 5, and you'll notice something similar for these as well. That would be 4 and 4, and this one our A value of 5 and 5. So what you're going to be doing tonight is you are going to be looking at a Delta Math graphing. You will need to look at these notes from today as well as the notes from yesterday that we took. So you'll want to go back, and if you didn't watch the end of the video yesterday, you'll want to make sure you have it on your roses, your circles, your line, and your circle centered at the origin. And you'll be working on graphing some of these on Delta Math.